Welcome back, everybody. Now we've got to move on to the second derivative. So the second derivative, when we're talking about implicit differentiation, is represented by this symbol right here, d2y dx2. We see the 2's, and that's symbolizing the second derivative. In order to get the second derivative, we've got to derive the first derivative. All right, so we're going to start with the first derivative, or we have to get the first derivative and then derive it again. But when you are trying to find the second derivative, it will most likely require you to use the quotient rule. You'll see that in a second. One thing to keep in mind at the very end, we want our answer in terms of x and y, so we don't want a dy dx in our answer. I'll come back to that. Let's take a look at the first equation that we derived implicitly. X squared plus y squared equals 25. This was the equation of a, it's this equation of a circle. And when we derived this the first time, we had 2x plus 2y dy dx was equal to 0. You all started off with that, and it was a struggle back then, but now it's much easier for you to do this. And then we subtracted 2x from both sides, so we have 2y dy dx is equal to negative 2x. And divided by 2y, so we got dy dx was equal to the opposite of x over y. Hope everybody doesn't mind, I canceled out the 2's there. So we just have the opposite of x over y, that's our dy dx. We now want to find the second derivative. That means that we have to derive both sides with respect to x. In essence, what we're going to do is we're going to derive the left side, and we're going to derive the right side, because we're allowed to do that as long as we do the same thing to both sides of the equation. Well, the derivative of the first derivative is the second derivative. So really, what happens on the left side is that we go immediately to d2y dx2. That's good. We're going to have our answer right over here on the right side. We're not going to have to move anything over from the left side of the equation to the right side of the equation, or vice versa. What we do have to do, though, is take the derivative of the opposite of x over y. Well, that's a quotient, so we've got to do the quotient rule. All right, quotient rule says bottom, d top, the derivative of the opposite of x will be negative 1. We all know that. Minus, now we keep the numerator, top, and then d bottom. The derivative of the denominator, the derivative of y is 1. I'm not going to write that 1, but keep in mind, whenever we derive a y, we need, yes, dy dx. So we have our dy dx all over bottom squared. So we have y being squared. Okay, so now we've taken our derivative. The problem that we have at this point is that we have 1, 2, 3 variables. We have x, y, and dy dx. We only want our second derivative to be defined by x and y. So we got to get this dy dx out of there. Well, we know that dy dx back here was equal to the opposite of x over y. So by quick substitution, well, let's do a little simplifying as well. Y times negative 1 will be the opposite of y. Double negative here, so we'll have plus x. And then now we sub dy dx out, and the opposite of x over y in to our numerator. This is all over y squared. Okay? So there is an unsimplified but correct second derivative, and that's something that we can stop right there. We don't need to go any further. Anything that you do from this point on would just be algebra, and hey, we're in calculus class. So we got d2y dx2. Here's our second derivative.